Hi everyone. In this video, I'm going to do some error analysis for text decomposition using Haiku 3.5. This is part of my AgentFastbook project where I'm attempting to automate the curation of a information retrieval dataset using LLM APIs. And this dataset curation process is going to be split up into three parts. First is text decomposition. So I have a question and then I have a gold answer. And the gold answer I'm decomposing into unique answer components that each are related to a particular concept. The next step is retrieval. So I'm going to take that answer component and try to find the passages that are relevant to it. And then the last step is text extraction. So I'm going to take those retrieved passages and then extract text from it and store that in my data set, and I will then have a question, answer, context kind of triplet for each dataset item. So this is still early, and I'm still trying to figure out how exactly things are going to work. So what I've done, building off of the last video, is I've added this notes text box, and I'm going to write notes here. And the first round of evaluation, I had just kind of intuitively come up with some metrics that I want to measure. So these are the ground truth components for this gold standard answer, and there's 8 of them. So for example, the gold standard answer here is this entire paragraph, and I had manually split that into 8 answer components. None of them were missing, which means that Haiku decomposed the gold answer into components in such a way that none of the components I had addressed were missing. But there were a lot of partial matches. And so, for example, here, out of the 10 components Haiku generated, 1, 2, 3, 4, 5, 6 of them are partial matches, 2 of them are exact matches, and then 3 of them I would consider extra components, so things that I didn't consider as a component. I also want to take a quick look at the overall metrics that I evaluated on the dataset. So looking at a component level analysis, there were 138 total components across 31 questions that Haiku had generated. And 22% of the components were an exact match, 71% were a partial match, and then there were some extra ones, very few hallucinations, and very few missing components. And if we look at the 31 questions, half of them had at least one component that was an exact match. 87% of the questions had at least one component that was a partial match. 23% of the questions had a component that I would consider extraneous, and then 6% had a hallucination or a missing component. So in this video, what I'm going to do is I'm going to walk through every question, all 31, and I'm going to write notes about what I'm observing about these components. So this is going to be a bit more subjective. I mean, you could argue that these exact match, partial match, etc. were subjective. I guess the exact match was not subjective, but basically this is me saying, what am I actually observing as I look at this data? And then I'm going to take those responses, I'm going to give it to Claude or Gemini, and I'm going to see what it thinks about the different themes that it sees across my observations. And then if I have time, hopefully in the same video, I'm going to plug in and evaluate the Claude Sonnet 4 generation. So I did the same exercise, and instead of Haiku components, I have Claude components or Sonnet 4 components, and I'm going to do the evaluation on that, do the error analysis on that, and then look at the results. So not sure if I'll pack all of that into one video, but we'll see. So here are some sample notes, so I'm going to delete those. All right, so looking at the partial matches, I think we'll start there. So here's this ground truth component. There are 2 subfolders, train and valid. The former contains the data for model training, The latter contains the data for validating model performance after each training step. Haiku has split that into three. There are two subfolders, train and valid. The former contains the data for model training. The latter contains the data for validating model performance after each training step. It's hard to tell without doing retrieval, and this is a theme that keeps coming up a lot, that it's hard to tell without doing retrieval whether or not it's okay that Haiku has done this, but still I will just make the observations that I can make, and then we will come back to this when we do retrieval. So I'll say Haiku does a more granular decomposition than me. For example, this one is split into three components, and let's grab this. This one. And then this one. So that's one observation. Evaluating the model in contrast to the often are used for training. So this one's the opposite. And so I'll say in another case, Haiku combines ground truth components that were separate. So this one here Haiku is the combination of this one and this one. And what do I think about that? Well, evaluating the model and the validation set to report a human interpretable metric such as accuracy. Yeah, I don't have any strong thoughts on that. Let's look down here. Every practitioner could generate their own. Let's see, I think that's an extra component. I'll say Haiku also generates components that I did not. So I'm just thinking as I write these notes, is this helpful, right? Like, for example, I could give Claude or Gemini my evals.json, and I think it could come to these conclusions on its own. Not 100% sure. So I'm not sure exactly if this is how I want to do it, but this is what comes to mind right now. And so I'll do that. But I think let me just write here, I think that the extra components might have relevant passages from the text, but I don't consider them important to the gold standard answer. On the other hand, there might not be relevant passages for those components, and so they should be removed from the data set. Okay, let's do that for now, and let's go to the next one, and let's go back and make sure it saved it, which it did. All right, this is question number 2, and I'll put myself up here. So this is a single ground truth component, and the single ground truth component is split into 7. So I'll make a note here and say Haiku has 7 components, whereas I determined that the entire answer could be addressed with a single component. Also, these two here, Haiku also generates 2 additional components and so if we look at the question, explain how the pixel similarity approach to classifying digits works. Now that I'm looking at Haiku's components, it's actually not incorrect. So I'll say which I think are actually useful to have. So for example, this sentence here, in the pixel similarity approach, we generate an archetype for each class we want to identify. So I'm going to say, I did not consider that as a component, while Haiku did. Upon reflection, this is a good summary of pixel similarity. So yeah, I think that there's something about that that might actually have implications about how I'm structuring this dataset item, and it might actually change how I think of it. And then in our case, we want to distinguish images. So this one I think is less important. The second extra component is less important, informative, but could help find relevant passages in the text. So I could imagine that, especially if I'm doing some kind of semantic search, I could imagine that this sort of text might actually help find relevant passages. And then there are some components, I'll say there are some components that are not fully structured sentences, which I don't think will be useful for retrieval. And then this is an example. And I think that's the only one. And then the last thing I'll say is to be determined, but I would imagine that some of these components will retrieve the same relevant passages. So we might have some duplicates in this process. Cool. And I'm going to check that it's saved. Okay, this one is about list comprehension. Again, I have a single ground truth component, and then this is now giving 3 different components. Do I have any thoughts about this? Well, so there's this missing, so I'll note that Haiku does not generate components for the example code in the gold answer. Not sure if this is relevant for search. So I don't remember if this example was from the text or if this was just an example in the solutions wiki. As I'm not sure this example was in the text. If we look at the Haiku components, lists are often generated using a for loop. A list comprehension is a Pythonic way of condensing the creation of a list. List comprehensions will often include if clauses for filtering. I will say that the Haiku components do make sense in that they are unique concepts that each could potentially have their own relevant text. Cool. All right, this one is about the rank 3 tensor and what that is. And here there's 8 Haiku components, and I have 6. The first 2 are exact matches, so are the last 2. The scalar, vector, and matrix, and a tensor of rank 3. Let's see. So scalar, vector, matrix, those are all in this one. All right, so this one here. A tensor of rank 3 is a cuboid or a stack of matrices. That's this chunk here. And then I'm considering this to be an extra component. Now that I think about it, I'll say even though I have considered this in that as a extra component, and I'll say I didn't include that in my component. I now think that Haiku is actually correct in including that. Including that because I did include this in the rank 1 example, as well as the rank 0 and rank 2 examples. So I think that is fine. And actually, Haiku did a better job than I did at pulling out that information. I think that's everything I want to do there. What is the difference between tensor rank and shape? How do you get the rank from the shape? Here we have 6 to 6. However, 2 of them are missing, so there's 4 exact matches. There is a partial match, and there is an extra component. We just need to find its length to know its rank. This is done as follows, and I don't have that in my ground truth components. Similar to the pixel similarity one, I think this is actually a relevant one. So I'll say I flagged that one as an extra component, but now I can see that it actually is a good summary of the answer and might be helpful in retrieving passages. So I think that extra component is extra, but it's not unnecessary. And then for this one, it has this, but it doesn't have this text here. And what I'll say for that is that Haiku doesn't include that in the corresponding component, which could be useful text for search. And then this one here, this ndim, you can also get a tensor's rank directly with ndim, and I'm not sure if that's going to be relevant because we have this here. Same thing for here, like this explanation is here, so I'm not sure if that's necessarily helpful. So I'll say which I'm not sure if it will be useful, and I'll say same goes for my component, this one, that Haiku did not generate. Okay, what are RMSE and L1 norm? 3 versus 7. Okay, so there's one exact match. Two commonly used methods of measuring distance. My ground truth component is, again, just a reminder that I, technically, quote unquote, cheated compared to Haiku when I generated my ground truth components, because I was looking at the text and then looking back at my component, then looking at the text and looking, I was kind of making determinations of what the component should be based on what was being retrieved. That's also going to take place in this project, because what I'm going to do after I evaluate Haiku and after I evaluate Sonnet for this task, I'm going to do a retrieval with them and then come back and evaluate the components. So ultimately, I think that back and forth process will be mimicked with my agents, my LLMs, APIs. But I think for now, some of this discrepancy we're seeing is that I've just put in a lot more thought than Haiku has for this first round of Haiku components. However, I think what I would say for this is, without knowing relevant passages, Haiku has done a good job of decomposing the answer into unique components. And the reason I'm saying that is because this one and actually there's one more. This one and are indeed unique idea, like self-contained ideas. Contained ideas that I had grouped into a single component, probably because the relevant passage contained all that information together. And I could also look at that right now. So let me actually pull that up. So if we look at what are RMSE and L1 norm, and we look at that in the actual text, let's see. So we have these two answer components, and they both correspond to this context. So take the mean of the absolute value of differences. So that's this. This is called the mean absolute difference, which is what that is. Or L1 norm, take the mean of the square of the differences, take the square root. This is called RMSE. So yeah, as you can see, like these two components are, similarly packed into here. And now that I'm looking at this, I just realized that this is actually a list. So I'm going to have to fix that in future evaluation. So if I go back, let's see if any of the other ones had that as well. No. So let me make a note of that as well. I'll also say to do my first ground truth component is actually a list of two components, which should, let me say, in a future iteration, I need to make sure that these are considered two answer components. And I'll think about that because, like, they are grouped together, right? I didn't because they are similar. And the reason that they are similar, you can tell, is because they relate to the same chunk of context. So root mean square is L2 norm, mean absolute difference is L1 norm. That's kind of tucked away here. So here is L1 norm, and then, oops, and here's the root mean squared error is L2 norm. And then the simplest would be add, da da da. The explanation of what they are is like packed into the same context as well. So I'll also add, I'll just say, not sure if I'll keep this as is. Okay. I think that's a bit ambiguous, but I don't want to overdo it on thinking about that one. So let's keep moving. So let me just make sure there was nothing else that I missed. Yeah, I think that's fine. Okay. How can you apply a calculation of thousands of numbers at once, many thousands of times faster than a Python loop? Let me put myself down here. This is a similar, I think we're seeing a similar example here. Haiku has multiple partial matches, and I have grouped ones. And then if we look at, here we go, how can you apply? Loops are very slow in Python. Python is slow. Using NumPy or PyTorch will be thousands of times faster. NumPy arrays and PyTorch tensors can finish computations many thousands of times faster, so that's there. Underlying C code, it does the whole calculation in C, tens of thousands of times faster. So this is a good example of how it's pretty fuzzy on how to match up answer components to the context. And I think that's good. Like, I don't think it should be, nice, cut and dry. Like, I think it's a good part. It's a good experience for like a real life Q&A dataset curation that I have to think about some of these fuzzy things. So if I look at this answer component, technically, I think both of these contexts combined would address everything in here. Or what I should have done, as loops are very slow and then thousands of times faster, that should have been one component, and that corresponds to this first one. And then as they are using underlying C code, which is much faster than pure Python, that should have been a second component. So as I'm thinking about this now, let me make a note of that. So I think I should have decomposed my first ground truth component into two components. So the as loops are down to NumPy PyTorch, and as they use underlying C code, because there are relevant passages, I'll say because there are two unique relevant passages in the text that match each one separately. And then if I look at what Haiku did, Haiku has this one and this one, and then loops are very slow. So if we go back here, loops are very slow. So you could even, break this down further. I'll say looking at the relevant passages, you could even break these down further, since loops are very slow in Python, is itself a chunk in the text. So, in summary, Haiku's decomposition might actually better match the relevant text. So that is interesting. I will, again, this is going to come up a lot, but the retrieval step is going to tell us a lot about whether or not these components are legit. Part of why I'm doing this process is I'm trying to understand and get a sense of my data as well, because I curated this benchmark like 6 months ago, something like that, maybe now 7 months. And I'm forgetting all these nuances. So doing this process is also helping me get up to speed. Yeah. So let's keep moving and let's go on to question 8. So for question number 8, we have what is broadcasting? And if we go down here, what is broadcasting? One answer component and one context, relevant context. So I have one component here. Haiku came up with 5. I would say in this case, just looking at these, some of the Haiku answer components are too granular in that they mean something else out of context. So for example, this one, so could mean any number of things, not necessarily broadcasting related. Broadcasting is fine. So this right here, broadcasting as an answer component is like a keyword. Yeah, like a keyword. This is fine. In the case of PyTorch, that's fine. Operations can be performed. I'll just say that these two might not trigger broadcasting related search hits, as they are somewhat out of context. Maybe not, like maybe this idea of expanded. Yeah, I don't want to say they might not hit. I'll say these two are more implicitly related to broadcasting than explicitly related. So that and that, which might be enough, right? Maybe that's enough to find an answer. Okay, sorry, I'm going to keep checking each time until I trust this app of mine. Are metrics generally calculated using the training set or the validation set, and why? And we have a few different ones. So we have 3 answer components. 3 answer components, exact match. So I'm just going to say exact match, no comments. Yay. What is SGD? All right. So SGD, or stochastic gradient descent optimization algorithm. So this is combining these two. This is combining these two. This is an exact match, and that's his extra component. So I'll start with the easiest one. Is not a useful answer component without context. Without more context, I'll just say Haiku generated answer component, and then I'll say that Haiku combines 2 pairs of ground truth components to create two longer components. TBD if this yields any issues in terms of retrieval. And I think the reason I had these as two different ones was that optimization algorithm is not in the context. So there's no part of the context that hits the phrase optimization algorithm for SGD. So it actually might not hurt. I'll say that optimization algorithm didn't have any hits in the chapter text. So it may not hurt, or well, in the chapter text in relation to SGD. So including it may not influence the retrieval. Cool. Why does SGD use mini batches? So we have 3 of these making up this one. We need to calculate our loss function on one or more data points. We cannot calculate on the whole data set due to compute limitations and time constraints. If we iterated through each data point, the gradient will be unstable and precise and is not suitable for training. And then these two, 4 and 5, make up number 2. And then this one is an exact match. So the reason I've combined these 3 into this one here is that calculate the loss, whole data set, but that's not ideal, very long time. Calculating it on the single is imprecise. So yeah, so I'll say the reason, so I'll start by saying that Haiku components 1, 2, and 3 combined are the same as my ground truth component. Component 1. I combined those concepts into one component because the chapter text relevant to all 3 was in one paragraph. Now, you could argue, now that I'm thinking about it, you could argue that we need to calculate our loss function on one or more data points. We could just take that sentence, and then we cannot calculate the whole data set due to compute limitations. Could be calculating it for the whole data set would take a very long time. So I think I could, I'll just make a note that I think I could split let's use the actual text. Split this into the 3 parts that Haiku has generated, as each part has 1 or more sentences in the text relevant to it. So I think this is one case where Haiku's granular decomposition matches the chapter text. Cool. Okay, hold on. Let me open up the evals file. So just looking at the JSON file, and here's my notes. Here's notes. Here's notes. So yeah, it is saving it correctly. So that's good. Okay, what are the 7 steps in SGD for machine learning? So I have 2 here, which is redundant. So I'll make a note. I'll say to do, combine the context for my repeated ground truth components in the existing dataset. Okay. Initialize the parameters, calculate the predictions, calculate the loss, calculate the gradients, step the weights, repeat the process. So I think this is another example where initialize, let's see, here's loss. Now that I'm looking at this, so initialize the weights. For each image, predict based on these predictions, calculate its loss, calculate the gradient, step all the weights, repeat the process. So initialize, calculate predictions, calculate the loss, calculate the gradients, step the weights. So I think this is a scenario, I'm just going to say, this is another scenario where Haiku's granularity will match up one-to-one to each sentence or bullet point in the chapter text relevant to this answer. Random weights work pretty well. I'll say works pretty well is a Haiku component that doesn't make sense out of context to granular. The loss function will return value based on the given predictions and targets. Lower values corresponds to better model predictions. That's what is loss. And lower value, so there's multiple contexts where lower values correspond to better model predictions makes sense. So I think for this one, yeah, I'm just going to say not sure how granularity will affect retrieval. As a Haiku component, probably doesn't make sense out of context on its own. Why can't we always use a high learning rate? Okay. The loss may bounce around, oscillate, or even diverge. The optimizer is taking steps that are too large and updating the parameter faster than it should be. I think these are okay. I would actually challenge that my ground truth component might not make sense out of context. Although it may work for a keyword search. Haiku granular components TBD if Haiku granular components work for retrieval. Question 16, what is a gradient? Oh, exact match. So let's say exact match. No comments. Love this. Do you need to know how to calculate gradients yourself? This feature known as differentiation in PyTorch. Manual calculations, the gradients are required. Deeper. Yeah. Let's see. So this one, manual calculation of gradients are not required, as deep learning libraries will automatically calculate the gradient for you. We mentioned just now that you won't have to calculate your gradients yourself, so that's corresponding to that first one. PyTorch will automatically. So yeah, I think chapter context contains separate sentences corresponding to each of the Haiku partial match components. So it should be okay to keep them more granular than mine. Why can't we use accuracy as a loss function? Because it's not smooth, or I guess it's not continuous. I shouldn't say it's not continuous, but it doesn't change with small changes in predictions, in activations. So, if there are slight change, oh, let's see, hold on. So exact match, loss function needs to change as weights are being adjusted. Accuracy only changes if the predictions change. So if there are slight changes, so that's this one. If there are slight changes, improves the confidence in prediction, does not change the prediction, the accuracy will still not change. I see. So that's actually the correct answer. The gradients will be 0 everywhere except when the actual predictions changes. The model cannot learn from the gradients equal to 0. The model weights will not update and will not train. So that's an exact match. And then this one here, so I'm going to say this Haiku component doesn't make sense out of context. This one, accuracy only changes 3 to a 7. Yeah, that might be kind of related. No, not really. I'll just say is not really relevant. Is not really found in the chapter text. So that handles the extra components. So let me just make that note. Looking at the extra components. And then if we look at, oh, here's another one where we have, no, we don't have a list. Okay, oops. Accuracy only changes when the model changes. Small changes, and then gradients will be 0. So I think the granularity won't matter. And I'll say for the partial matches, separate sentences in the chapter text match the separate Haiku components. So I don't know if this is going to work, right? Like, I could be wrong that it's too granular and it doesn't find the right passage, but I'm just using my intuition for now, and we'll test that out. And I think that's good enough for that. Okay, partial match. So we have one ground truth component. And the key difference is that metrics drives human understanding. Losses drive automated learning. That's a separate sentence. Needs to have meaningful derivative. I would actually say that let's see. Oh, it is. Here we go. The loss might be a meaningful derivative. So yeah, driving automated learning and meaningful derivative are part of the same sentence, right? To drive automated learning, the loss must be a function that has a meaningful derivative. And this is the context. This is the chapter text. So that granularity might cause redundant results. So I'll say for the haiku components and the chapter text relevant to them is a single sentence, which might lead to redundant retrieval results. That's the best case. Or each component on its own is not enough context to find that single sentence. And that's our worst case. TBD how this works out. So that's those two. Many metrics like accuracy are not like that. That really didn't factor in. Metrics are numbers that humans care about. That's a bit redundant. And let's see, reflect the performance of the model. Let's see. So I think that's a to-do. This haiku component points out an unaddressed answer component that is not addressed. Let's just say component is not addressed by the gold relevant context in the data set. Might need to add context for that component. So again, this is an example. Let me just write this out. This is an example where haiku generated components inform me about gaps in my current data set. Okay? Exact match. Hooray. No comments. The data loader class can take any Python collection and turn it into an iterator over many batches. I think even though haiku has split my ground truth component into 3 separate ones, each one might act as a keyword during search. TBD how this works out during retrieval. So another one where we'll just have to let our retrieval process tell us if it works or not. Okay. And then here, without changing its contents. So I think haiku component might not make sense out of context. What are the bias parameters in the neural network? Okay, without the bias parameters, if the input is 0, the output will always be 0. Therefore, using bias parameters adds additional flexibility. Okay? Okay. We'll be flexible. You might remember. Yeah, I think this one yeah, this is another one. I'll just say this is another example where two granular components will best case retrieve the same context, or worst case will not be sufficient to retrieve the single sentence gold context for this answer. Yes, exact match, no comments. So I think we've had like 3 questions where it's an exact match full across the board. Yeah, this one, I'll say 2 of the haiku components returns, and this method are likely too granular out of context. So we'll see. I think current gradients is the strongest. The current gradients is the strongest match for the gold context. Why do we have to zero the gradients? PyTorch will add the gradients of a variable to any previously stored gradients. Yep, that's there. If the training loop is called the gradients will add to the previously stored gradient value. So, to do, dataset currently doesn't contain context directly, or I would say explicitly, addressing this part. TBD if chapter text contains relevant context. So the chapter text does talk about previously storing, but it's not talking about explicitly the adding, like the accumulation of gradients. So that might be an adjustment to the data set. What information do we have to pass to the learner? Yeah, this one is interesting because the data loader is the model. Yeah, I think this might be a case where the granularity of the haiku components, hailu every time, dilutes the retrieval results. Whereas combining them in a single sentence makes it easier to find because the gold context contains all components in a single sentence. Okay, and that's great. It is a commonly used activation function. Let's see if that's in here. I'll ignore. Yeah. So I think might not have any retrieval hits, as it might not be a phrase used in the text. Potential to do, remove that part from the answer components. So again, just going to highlight another scenario where Haiku's components are helping me improve the dataset. Okay, what is an activation function? We have 2 exact matches, an extra one, and partial matches. Okay. Interesting that without an activation function, we just have multiple linear functions in the form y equals mx plus b is extra, but let's see the function, a series, or model. Yeah, this context, there's no point in just putting one linear layer directly after another one would relate to that. So potential to do, add this to answer components. Exact matches are fine. By introducing a nonlinearity between the linear layers, this is no longer true. This is no longer true. This is no longer true. Each layer is somewhat decoupled. Yeah, that's fine. So I'll say that Haiku, oh my god, Haiku components, this and this correspond to separate sentences in the chapter text, which okays the granularity, in my opinion, currently. And then it can be mathematically proven. This is known as the universal approximation theorem. Yeah, I'll say same goes for this and that. Oh my god, we're so close. What is the difference between f-ReLU and NN-ReLU? Okay, let's look at that. NN-ReLU as the same thing as f-ReLU function. So that's, I think that can't be separated. It's one sentence. Most functions that can appear. Yeah. So another example where Haiku component granularity needs best case yields redundant retrieval results, and worst case are too granular to provide enough context. TBD. Okay. And then here's one where we have one component, but Haiku has 5. More than one linearly, we can use deeper model, better performance, faster training. So Haiku components and are too general and may dilute retrieval results. And then looking at these first two, yeah, you could argue that this component is not explicitly found in the text, whereas this is, but the former puts the latter into context. TBD on how they perform separately during retrieval. Okay, so that is it for this part. Now I'm going to open up a notebook and we're going to extract these notes and then we're going to give them to, let's just do Claude for now. So pause the video, set that up, and then we'll continue. Okay, so I have this here. I've loaded my evals.json. So if we look at the first one, and yeah, here's my notes. Cool. So here's my notes. So I think what I'm going to do is make a string, and we'll say notes. And then we'll say for item in evals, I'm going to do note. Item notes. Yeah, let's see how that looks. What's going on? Oh, yeah. Oh. Oh my gosh. Okay. Good. All right, so let's see. So notes, note, and then we have note, and they all end with a ending thing. Okay, so I think that looks pretty good. To-dos in there. Here's some of the last ones. Explicitly not found. The former puts the latter into context. Okay. That, I think, looks good. So I'm just going to go and grab this, copy, and I'm going to give Claude some context. I'll say, I just finished doing some error analysis on a text decomposition task where Haiku decomposed gold answers into answer components, where each component is a unique concept idea that requires its own definition explanation. I then compared these Haiku components to my ground truth answer components and wrote down comments noting my observations on the pros, cons of how Haiku decomposed the gold answer text. Attached below are my notes. Can you please do the following? Summarize my notes in a couple of paragraphs as if you were writing a report. And then 2, give me a list of themes, shared themes or common themes across the notes. Make sure to include a theme even if it only occurs once. Be concise and use partial sentences for this bulleted list. All right, I think that's decent. Yeah, and we'll use Sonnet, extended thinking, and normal is fine. I'm going to say concise. All right, let's see what it does. parsing, theme extraction. Okay. Error analysis reveals significant differences in decomposition approaches between Haiku and the user's ground truth methodology. Haiku consistently demonstrates more granular decomposition. That makes sense. Often better aligns with the actual structure of the source text, where separate sentences or paragraphs address each subconcept. However, some granular components provide better text-to-component mapping. Others are too fragmented to be meaningful out of context. Yeah, we saw that for sure. Yep, Haiku's decomposition serves as a quality control mechanism for dataset development. Haiku frequently generates components that the user overlooked, some of which prove valuable for comprehensive coverage. The granularity differences raise critical questions about retrieval effectiveness, whether multiple granular components will retrieve redundant results or fail to provide sufficient context for accurate matching. Overall, Haiku's approach appears more systematic in matching text structure, but potentially less optimized for practical retrieval applications. All right, common themes: granularity mismatch, additional component generation, context dependency issues, text structure alignment, retrieval effectiveness concerns, dataset gap identification, exact match scenarios, over-fragmentation risk, keyword versus semantic matching, and redundant retrieval potential. So that is pretty interesting. One of the things that I was reading Hamel's FAQ on error analysis, and it said that doing error analysis is what should inform your metrics, right? So right now, I have exact match, partial match, extra components, hallucinations. But I think this is now getting closer to what I'm actually trying to capture, right? I'm trying to capture retrieval effectiveness concerns. I'm trying to capture context dependency issues, which are kind of related, right? So dataset gap identification is not a failure mode. It's actually kind of constructive benefit. Exact match is not a failure mode. Over fragmentation risk. Keyword versus semantic matching is not a failure mode, but is an interesting thing. Redundant retrieval potential. So I'll say I would combine context dependency issues, over fragmentation risk, and retrieval effectiveness concerns into a single category. Do you agree? Don't just agree with me. Think for yourself. About semantic clarity, components meaningless alone, like works pretty well. About appropriate scope size, components too small to be functionally useful. Broader questions of whether approach works in practice. A component might be contextually clear but still over-fragmented, or appropriately sized but context-dependent. Retrieval effectiveness encompasses both plus other factors. Can you give me examples from the actual notes? Works pretty well. Unclear referent, missing subject, no clear antecedent. Context dependency issues. Over-fragmentation, broadcasting, just a keyword. This is what SGD does, too minimal to be useful. Could mean anything out of context. Oh, I see. So it seems like All right, let me read the rest. This might be a case for the granularity of haiku components dilutes the retrieval results. Best case, TBD. So, okay, so it seems like context dependency issues are more grammatical issues in the sense that they don't make sense in any context, whereas over fragmentation risk is not about grammar issues, but about how the component's phrasing might affect retrieval, maybe? Is that what it's saying? Okay. All right. So we'll keep these as is. I'm going to copy these for now, and I'm just going to say Haiku 3.5 themes. All right. So I think there's a good case for incorporating these in my annotation tool. However, before I do that, I want to use a stronger model because maybe some of these issues are there just because Haiku was the one doing the thinking. So what I did is I basically ran the entire process again, except I used Claude Sonnet 4, and then I saved that. So what we're going to do in this section of the video is I'm going to load up the Sonnet 4 questions or evals, and then we're going to go through and we're going to do the evaluation on that. And once we do that evaluation, we're going to compare the exact match, partial match, missing, extra components, hallucinations, scores between Haiku and Sonnet. And then I'll probably leave it for the next video to do the note-taking process for Sonnet, or I might just not do a video about that at all because I've already done that and it might be a bit quicker. I don't know. We'll see. So if I look at, this is my app that we're looking at in the browser. So I'm going to comment out this and I'm going to load evals sonnet.json and save evals. I'm going to save it as eval sonnet. And let's just make sure there's no, there's no evals.json left. And I probably, I accidentally still called it Haiku components, so I should probably call it like model components or generated components. I think what I'm going to do is I'm going to say model name equals sonnet 4. And then at least in some of these, I'm just going to do model name. Maybe that'll work. We'll see. Oops. Whoa. I'm going to leave some of these as is. All right. So let's see if this works. Let's reload this. All right. And let's go to, I think 0, right? Yeah. And let's start scoring these. So I have 8 ground truth components, and I have 12 sonnet components. So we have the same thing. It did partial matches here. Evaluating the model, partial match. This is an exact match. Exact match. And if this is working, which it seems like it. Oops. Exact partial, yeah, so it's updating it. So this seems to be working. Let me just open the JSON file and make sure it looks good. So here is exact. We have a couple trues. We have a couple partials. So I think it looks good. Okay. Overfitting model validation set. Facilitate the on. Wait, I guess that's not. So that's not a component. So that's interesting. So that's extra. Every practitioner could generate their own. Extra. Public data sets. That seems to be an exact, right? Yeah. Each subfolder. Partial. This is a common way. Extra. For the full MNIST, we have exact. Okay. And then each subfolder, evaluating the model on the validation set, facilitate, to report, public data sets for the full. So none of them are missing. So that's good. And then let's just make sure everything was saved. And yeah, let's check this. And these are updating. So that's cool. Okay. Okay. So basically everything's going to be, so this is a partial match, I think. No. It's extra. 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 Partial. 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 And none of them are missing. Okay, so our partials has gone up from 10 to 11. Or no, I see. Never mind. Yeah, it's gone up from, we can't really tell, but that's fine. Total questions analyzed, 31. That's not correct, but that's fine. Okay, lists, partial, 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 partial. So it included this here. Partial, list out. And then this last part it didn't include, so I'll just say that's missing. I think that's our first missing one. Okay, exact match. And missing is 1. Yeah, okay, good. Easy way to identify exact scalar. So partial, 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 partial. Actually, I'll say this is an exact match with extra components, but we already talked about this. This is not really extra. It's just my answer components did not contain that incorrectly. The rank of a tensor is independent of its shape or dimensionality. That is there. Oh, here we go. So that's partial, partial, and close enough to be exact. Great. Okay, exact, 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 partial, partial, partial. Let's see. Where is this even from? Oh, I think it's this one. This is done as follows. So that's extra, exact, and this is, call it exact because it's close enough here. And I think that's it. This is partial, partial. This is exact. This is partial, 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 and no missing. As you can tell, I'm going a bit faster because this is now the third time we're looking at this type of data. Partial, partial, using NumPy or PyTorch, underlying C code, operations on GPU, which will have speed up. Yeah, that's good. Interesting that Sonnet is not really, I mean, I don't know if it's better or worse, right? But it's not very different from Haiku's generations. This is a partial match, partial match, partial match, partial match, nothing missing. Partial match, partial match. I'll just say partial match, even though, there's some extra stuff in there that I didn't put, but that might turn out to be just more context that is not necessarily wrong. Okay, we got partial, exact, exact, partial, partial, extra. No missing. Okay, this is, wow, partial, 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 partial. We'll call it partial. And then this is exact. And none are missing. So, I don't know. Sonnet's not really impressing me here, but hard to tell until we actually do the retrieval. Predictions, training set, calculate the loss. Step the weights, update the parameters, repeat the process, stop in practice. Cool. Here we go. Similar result, or exact same result, exact same between Sonnet and Haiku. Okay, exact, exact, partial, partial, the same thing as haiku. Exact. Partial, partial. Partial, partial. Exact. This is partial, partial. Close enough to being exact. Exact. Partial, partial. Therefore, partial. Exact. 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 Extra. Extra. Cool. All of these are partial. Metrics drive human understanding. Loss drives automated learning. Meaningful derivative. Many metrics. Metrics instead. Performance of model. And nothing missing. Partial. Similar to haiku. Similar to haiku. Yeah, same thing as haiku. That's interesting. Data loader is the model. Yeah, this is the same as haiku. Same as haiku. This is extra. Okay. Right, nothing missing. Okay. Interesting that better performance, faster training. These were not things that haiku did. Okay. All right, so we have now a bunch of data for this one. So let me load this up in here and then we will take a look. One sec. All right, so now I have my evals Sonnet 4. So I'm going to copy this, put this here, and this is going to be Sonnet 4. And I'll say Sonnet 4. And let's see if this works. Oh, I forgot this. So let's run this. So just real quick, haiku was 71% partial, 22% exact. Those are the main ones. Interesting. Sonnet was actually worse, 5% less exact, 6% more partial. No hallucinations, so it did better in that regard. Extra was the same amount. Missing was half as much. And then 39% of our questions had at least one exact component. We're 9% more for haiku. That's very weird. 87% partial, 97% partial, 26% extra, 23%. So that is interesting. I don't know what to make of that. So that's something I'll have to think about. I think, this is just anecdotally as we were going through the video. It didn't seem like Sonnet was doing anything that differently. It had some extra components. It had fewer exact matches. So I didn't get the sense that there was like any more insights that I would be able to gain other than these ones here. So I think based on that, I don't think I'm going to do more. I don't think I'm going to do the notes for Sonnet. I think what I'm going to do now is I'm going to do retrieval with one of these LLMs, and I'm not sure exactly how to do that. I don't know if I should just give it the chapter text or get chunks. I don't know. There's a lot of decisions there. I think my initial intuition or initial attempt might just be like, I might just give it the entire chapter text and then give it the answer component and ask it to find it. That's going to be probably a lot of tokens, so I'll see how much one token takes, like, because I have 138 components, so, you know, I'm happy to spend like $5 on it, but not $50. So I'll have to see like how that makes sense. Might make a video where I'm thinking through that. It'll be a less polished video. I mean, this was not polished, but it'll be less polished than some of my other videos, but it definitely helps me to think through these problems as I talk through them. So main takeaways, we got some common themes, and these are really helpful. And I think ultimately a lot of these questions, especially retrieval effectiveness concerns, context dependency issues, additional component generation, granularity mismatch, text structure alignment, overfragmentation risk, keyword versus semantic matching, redundant retrieval potential. Basically everything except exact match scenarios and dataset gap identification is going to be answered or addressed by the actual retrieval step. So that's going to be my next step. How do I do retrieval? TBD. I'll probably make a live think through this problem video. We'll see. Regardless, thank you for sticking around until the end, and I will see you next time.